Assalamualaikum. So let's continue to the part 3. We are still on the introduction, chapter 1. So let me share with you the PowerPoint. Um, so we are stopped somewhere at here. Um, okay, so let me see. Let's see here. So we are on the last video. So this is the benefit of machine vision. I did cover this one. So let's see some video here. So this is the machine vision. Okay, so that's all the video example of the application of machine vision system. So a lot of application where you can search in the YouTube. Okay, so let's continue the last slide. So this is the basic concept of machine vision. Um, Actually, when we talk about machine vision, so the machine vision, the concept of machine vision, it must have a camera to acquire an image, software to process. Software is like a brain, our brain. Camera is like eye, and then the software will make decision. So that decision, what you need to do with that decision. So interface with the hardware. For example, if we do the inspection, uh, quality inspection of reject and good. So what we want to do when the object is reject? Then we interface with the hardware. So this is the software and hardware. A vision system include hardware and a software component. we have a hardware camera, computer, image processing, and display. So one or more digital cameras. This is the first concept of the machine vision. We need to have a camera for to capture an image. So a lot of camera, a lot of types of camera that we can choose for the machine vision application. So this is the example of an of a camera, right? So um, the higher the specification of the camera is better, but it is also must be depends on the budget. Uh, if we use expensive camera, so we can get a good data, but the cost of the system or the machines is expensive. So the second one, the light control. We sometimes need to control the light because the light uh, will affect the data. If we don't control, then it's sometimes difficult to do inspection or to process the image. So this is the example of light of the box, or we call it chamber, to control the light. Sometimes we use a sensor to capture image. Okay. So camera next is a software. When we capture the image, then we need to process the image. So we use a software to process it. So this is all the software available: coordinate extraction, metros, all the ready-made machine vision software. Or we can use a basic software like OpenCV, C++, Python. So it is more cheap compared to the available or third-party software. Okay. So this is another example of software available for image processing. So when come to the detail of software, uh, so what is actually image processing done? So this is the main topics in image processing. Uh, Fundamental of image, pixel value, filtering, color, age, shape, so on and so forth. So we need to have this fundamental knowledge in order to process or in order to develop a coding for machine vision system. So last one is hardware. When we process, we make a decision. So that decision we interface with the hardware. So the interfacing can be use communication link, profit bus, Ethernet, so on, and we interface with the hardware to automatically reject or accept the components or the object. So let's have a look at this video. This is one of the company called Next. Published company. So they have these three designs. Okay, so that is the example of a product that available in the market to perform the machine vision system. Okay, so next, image processing, the basic of image processing. So this one is already covered in the first um, part of the video. So what is digital image processing? Digital image processing is electronic data processing on a 2D array of numbers. The array is a numeric representation of an image. In general word, image processing equals to application, detection, recognition, enhancement, classification, security, encryption, and etc. So this is the example of digital image processing for recognition, digital image processing for tracking. So this is, if we use for recognition, we recognize the object. Tracking, we recognize the object, then we track movement of the object. So fundamental step in image processing, we must have a camera for image acquisition to acquire the digital image pre-processing, image segmentation, image representation. Image description, image recognition, image interpretation. Knowledge about a problem domain is coded into an image system in the form of a knowledge database. So this is the step, the concept of the image processing. But sometimes you when you have this knowledge, all this knowledge, you need to have this fundamental. But sometimes later when you want to develop, if you go outside and work as an engineer and need to develop a coding for machine vision, sometimes you are not following this step. It's okay. You not even follow this step. Maybe one or two step lah, image acquisition. It must, you must have this image acquisition. Sometimes you don't do image pre-processing, segmentation, representation. You just do one step, then you you complete the system. It's okay because now it's very advanced and very easy to develop the coding. So as long as you have the fundamental, then it is okay not to apply that fundamental. But if you don't have fundamental, sometimes you can develop the coding. So that's the situation, right? So because later when you work and need to do this the system, then you find out that you don't follow these steps. Then it's okay as long as you have the fundamental. It's easy for you. Okay. So this is the image sensing and acquisition. Images are generated by the combination of an illumination source. We need to have the source of light illumination so it can capture the image. So this is the type of camera. Okay, coordinates, FLIR. All right. What is the digital image? A common image format include one sample per point, black and white or grayscale, 3 sample per point, red, green, and blue, 4 sample per point, red, green, blue, and alpha. So when you have image, it is actually represented in this array. We call it row and column, row and column, row, column. So for each pixel, it consists of a value. So that value we call it pixel value, pixel number, pixel number. Okay. So if point, this is point, 1 point. So you just imagine if you have a very big size of pixel, even you can't see the point because it is very small. But this is just to take just to rescale to show you an example of the matrix of the image. 1 sample per point means that at this 1 point, it consists only one value. They call it 1 sample. So 3 sample per point, three value. So this is how the matrix looks like, sampling. Okay, RGB at one point they contains of three sample, 73, 66, 31. So that's RGB. So you have color image. At this point, at one point, it contains of three values, three values, RGB. An image represent in a pixel value, analysis of image for enhancement, detection, recognition, rely on pixel value, which is based on image size. Okay, so digital image representation, grayscale. So this is the example. If we take one sample here, matrix, so this is the value. One pixel, 1 point. Okay, we call it grayscale. So this is binary images. Okay, binary is 0, 1, black and white. RGB image is 0 to 255, and it consists of three array, RGB. So you can see the color. So this is the example. I just skip this one. Example for color image processing, color simplified object, color spectrum. RGB is color, CMY, YIQ is color. So this is the RGB. RGB model is combination of three R, green, blue. At one point, it contains of three RGB. CMY model. So more practical application. This is used for color phase detection. And RGB. Color based for the machine vision application. Okay. So that's about chapter 1. If you look at the slide that I just skipped just now, we will go to the details on the next chapter. Don't worry about that. I will explain in the detail on the next chapter. So till now, we stop here. We continue to the next short video. Thank you very much.